let's look at this. Let's look at the Decay lab here. Okay. So what you want to do is just pick one of these and download it, right? At least that's what I think you want to do, right? And then you want to open up a Google spreadsheet, okay? And inside Google Sheets, you want to go File, Import, okay? And then it's going to go to your drive, and that's probably on your Chromebook. It'll be on your drive. But for me, I downloaded it to my computer, so let's open that. Replace the spreadsheet, sure, I guess, I don't know. All right, that sounds good to me. There it is, all right. This is so the lambda that particular data is from is stored right there. I'm going to move that off to the side because I don't need, I guess I don't need that there because I want to put my units there. So this is time in seconds, and this is the number of nuclei, which doesn't really have a unit, right? It's like just a number. And then what we want to do is select all this data. And I wish there was like a quick way. You can put in the comments how you do this quickly. This is the only way I know how to do it. Actually, you know what? It'd be faster to do this. Just scroll to the bottom. It'd be faster to go click. Shift click. There you go. That's the power tip, right? All right. And then what I'm going to do is I'm going to insert a chart. And usually it picks the correct chart, which is a nice smooth line like that. If it doesn't do that, just go in here. I think, usually it's not a line chart because usually line charts don't have the correct axes, but I guess it is a line chart, so we'll just go with that. And what we want to do is we want to put a vertical grid line here every 10 seconds, so we have a little more accurate appraisal of the time. And then the vertical axis here, we want a major grid line every 220 nuclei. So let me show you how to do that. Go customize grid lines, and for the vertical axis, let's do the step value at 220. Let's see what that looks like. There we go. Okay, so notice that 1760 is the beginning amount, 880 is the first half-life, which is right there. 440 is the next half-life, and 220 is the next half-life. So the horizontal lines are already drawn for us. And then let's click on the horizontal axis. Let's make the minor spacing be step size of 10. There we go. If you pause, by the way, in the middle, type 1 and then pause, it'll show you a whole lot of grid lines. All right, so there we go. So now we've got, I believe, the grid lines the way we want it. Now, if you want extra credit, and I highly recommend this, what you want to do is go into, because you want to add a trend line, okay? So you want to go to Series, and you want to go trend line, okay? And linear is not the correct trend line, okay? So choose the correct trend line. Then you also want to do this. You want to label it. So click on this and then use the equation. Because when you do that, it puts the equation on the chart. Okay? I don't want the trend line, but there it is. Okay, so I think this thing looks the way we want it to look. So what I'm going to do is I'm going to copy this and put it in the assignment. Okay, so click this and click copy chart. So 3 little dots in the upper right hand corner, copy chart. And then go to your assignment, right? And then you're going to do a paste. Edit, paste. Simpler is linked means when you change it in the spreadsheet, it'll change here. I'm going to err on the side of being less complicated because I don't think I need to edit this at all. There we go. That looks good, right? Oh, wow, what did I just do? I've got one of these Apple mice, so if and then I don't think I need these. All right, so now what I want to do is I want to do the horizontal line or vertical lines, okay? So here is, notice right here is where the plot intersects 880. Here is where it intersects 440. And here is where it intersects 220. Right? So I want to put vertical lines there. So this is the line tool right there. Okay, click on that. And then the pro tip here is that you want to hold the shift key down. So find that intersection, hold the shift key down. You can't tell that I'm doing that. And what that does is it makes it snap to particular angles, one of which is, of course, vertical. And then click off of it. And look, and that looks pretty good to me. Okay, sometimes you have to nudge it left and right, but I think that one's good. Okay, and then I'm going to do another one. I want to do it at 440, so that intersection seems to be about there. Hold the shift key down. There you go. And then I'm going to do one at 220. So again, click the line tool. 220 seems to be about there. Now, hello. Now, the fact that these are fairly evenly spaced is evidence that this is a exponential. Okay, it's not 1 over t. It's not, obviously it's not 1 over t because this would be infinity here, right? Okay, so that's one of the evidences you have is that these things are evenly spaced. Now, just for kicks, click on the graph and do a control click, right? And I want to send this to the back. And then these guys, let's move these guys to the front, because sometimes front and back get mixed up. And then the spreadsheets, kind of like Photoshop and like Microsoft Word and stuff like that, deal with layers of things. So I'm going to right click this. I'm going to put this guy to the front. Just, I want to tell it, because right now it's just defaulting to some behavior. So make these guys be in the front. Make the graph be on the back. Otherwise, I think in Google Docs, it's annoying because it's the last thing you move is in the front. Right? So if you accidentally move the graph suddenly snaps to the front. And then when it compresses it and flattens all the layers and makes a PDF, it just randomly, messes it up. But Google Sheets or Google Slides actually has front, back, the order is built into it. And now we no longer really need this, the directions there. Okay. All right, so this is beautiful, right? We got all these points there. Notice that the first half-life seems to happen at 10, 20, 30, 40, 50, 60, about 75. The next one happens at about 150, which is about 75 later, right? And then the next one seems to happen at, well, that's a little bit off, right? 1, 2, 3, 4, 5, 6, 7, 85, right? So there's not quite a lot of agreement there, but we'll take a look here. Okay. So the first thing is you want to fill in all this stuff. Well, what is our lambda? Well, our lambda was, what was it? 0.09. 0.009. Okay. 0.009. What is the calculated half-life? Well, what you're going to do is you're going to take your calculator and go natural log of 2 divided by 0.009. Natural log of 2 divided by 0.009 gives me a number a little bigger than 75. Okay, so that's the calculated half-life. And now we need to figure out the time elapsed from between these numbers. So to do that, you got to go into your graph, or your data, right? So let's go in here. And let's find where 880 occurs. Okay, so I'm just going to scroll down. Let's find 880. Oops, it's somewhere in here. Okay, let's see. 880 is in here, right? This is the closest we have. So it's about 75 seconds. Okay. It actually happens a little before that. So this is our first half-life. Kind of. And if we were doing careful work here, we'd extrapolate or interpolate, actually. Right, so it's actually 74 point, I don't know, Oh wait, no, it's actually after 75. So it's 75 point something, right? Not much, 75.2 or who knows. Okay, now let's find 440. I hate it when it does that. Okay, let's see, 440. We're looking for 440. Whoa. Well, 439 is pretty close. So this is my second half-life. Okay, notice that that's 149. Okay, so the time elapsed is going to be $149. Whoops, I went right by it. 149. And here's our first half-life, right? The first half-life. Gotta hit enter. Okay, is there. So that's 75. So the time elapsed to the next one was 149 minus 75. Okay. All right, there's that one. Let's find, there's the second half-life. Let's find the third half-life, which is 220. 221. So here's the third half-life occurs there, right? So that one's going to be 233 minus 149, okay? So what you need to do is subtract these, right? So notice that this is 75 seconds. First half-life is 75. Second half-life is 149 minus 75, right? Third half-life is 233 minus 149, okay? So are they the same? Okay, are the three half-lives the same? My first was 75, the second was, I think, 74, the third was I don't know, you have to figure it out, right? Okay, so these are, you could just say, remarkably the same, or very close, or in the ballpark, I don't know, right? And then B, specifically, how does the curve suggest an exponential function? Give concrete evidence, right? So evidence that you could cite are the half-lives the same, right? If you did an exponential fit, that equation would be displayed up here, and that would also be evidence, right? So those two things are evidences that this is exponential. Less powerful is the idea that the slope here is decreasing, right? Because there's a lot of other functions that would have that same property, okay? Give evidence. Okay, how does the half-life you measured compare to the half-life you would calculate? Well, you calculated it here. You did natural log of 2 divided by 0.009. Right? When I do that, by the way, I get a number that's a little bit different from these. Okay, I don't know why. These numbers are all fairly close together, but that number is slightly different. So what you want to do is cite what it is. So the half-lives were in the ballpark of 74, 75, blah, 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 right? And this number was blank, okay? So say what that is, right? And then finally, take a look at the answer there, right? So at the exponential curve, if you actually did a exponential curve on there, and you displayed that function, which you need to do if you want the extra credit, okay? What you're going to do is look at the exponent that it gave you, and compare that to the lambda that is here, okay? The 0.009. All right, I think I've sucked all the air out of the room here. I'm going to stop talking.